Okay, so here are two examples on how to transform in scientific notation very, very fast. Remember the slide you just saw in your activity where it has a formal definition of scientific notation, okay? So what you have to do here, I'm just gonna erase that line. That might be easier, I just realized. Okay, I'm gonna pick a different color so you can follow me here. Good. You need to find if that number here, right, 75 billion, would have a decimal point. Let's say it would have a 0.5. The point would be here, okay? The decimal point will be here, and then you'll have like a 0.5, okay? It'll be right there after that decimal. But this is not really relevant. It's just for you to understand where is it that you have to start counting, okay? And from there, you have to start counting to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I moved my decimal 10 times. Remember, my definition stated that I have to bring my decimal until I have only a number here on the left-hand side of that decimal, one number between 1 and 10, 10 not included, okay? Between 1 and 10, 10 not included, or 1 and 9, right? 1 and 9, sorry. I should have said that at the beginning, sorry, okay? So it needs to be a number between 1 and 9 included. Good? So now I'm left with 7.5. If I would have had more numbers here, I would have written a few more, and I could round actually, because the point of using scientific notation, I've seen that before quickly. I had like something like this: 75, 492, 3, 8, 1, 6, 2, 9. The point of having scientific notation is so I don't have to write that big number. So I navigate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. I would write my 7.5 and I would put times, no, sorry. I could put maybe one more decimal or two. So I don't have to round anything. 7.549. You see, I can stop here approximately. It's fine. Okay, times 10 to the power of 10. Okay, and same thing here. So we move our lines 10 times, a little wiggle 10 times. So we're going to put it to the power of 10. And why is it positive? I like my students to remember it is positive because we made a very, very big number. We made it smaller. So we need to tell that to people. So it means it's like doing 7.5 times 10 times. It needs to become a big number. That's why we leave it positive. We turn a very, very, very big number in scientific notation. Exponent always positive, okay? Now, we are going to make a small number, very small number here, into a bigger number because we are going to find again our decimal point, but now we're going to travel to the other side. So try not to remember by heart, oh man, I'm going to the right or to the left. Is it negative or positive? Just think about what type of number you have here. Look, I have a number below, like between 0 and 1, so it's a small number. So it just means I'm making my number bigger. You're going to travel until you get to the first number. Remember, what's our rule? We need to have a number between 1 and 9. So what you're going to do, you're going to put your decimal, your 2, and your 1. I'm going to do times, and I moved how many slots? 1, 2, 3, 4. But I move, again, don't think about it, I move to the right. Think about it in terms of, I made a very, very small number into a bigger number. So I have to borrow 4 decimal places in order to be able to do that, okay? So you are going to be practicing this on the next slide on your own. Okay, I hope you guys are doing well. And Mr. Jackson and I will be here to help you.